Hi, my name is Alyosha and I'm working at Technical University of Munich with Professor Dr. Laura Leal-Taché. Several ideas presented here were conducted during my PhD at RWTH Aachen University under mentorship of Professor Dr. Bastian Leibe. To navigate around the world, mobile robots need to detect and track objects. Nowadays, this is usually done via tracking by detection paradigm, where the idea is to train object detectors for specific object classes, and then at the inference time, we detect objects in images independently and link them across time. This means that we need to be able to recognize objects before we can track them. For example, in this case, we had detectors for cars and pedestrians and we can track them well, but how about this child stroller here in the front? So of course we could go and collect and label data and train a stroller detector, but I think that this approach doesn't really scale to real-world scenarios populated by unknown dynamic objects. And because the frequency of object class observations follows power law distribution, meaning that some object classes occur very frequently, but the vast majority of them are observed only rarely, I think that we will never be able to obtain object detector for every possible object class. Inspired by these observations, in our past work, we leveraged large-scale datasets, such as Microsoft COCO, to learn to detect and segment objects in category-agnostic manner, to obtain per-frame object evidence. You can see output of our instant segmentation approach here on top. Category-agnostic training helps to generalize better to objects not seen during the training. Then we made use of parallax as a cue to identify temporally consistent object tracks under ego motion of the recording vehicle. The resulting videos you can see here. Different to datasets containing distinct samples of observed classes, robots experience a continuous stream of sensory data from which future mobile robots will need to continuously learn and model new object classes. To this end, we used our method to mine object tracks of known and unknown objects automatically from large-scale datasets. We found clusters of previously unknown objects, and we handpicked a few examples that we are showing here. Using these clusters, we managed to retrain object detectors and obtain new object detectors for these classes automatically. So here, for example, in Kitty dataset, we obtain a strip sign detector and transformer detector. On Oxford robot car dataset, a sign baller detector emerged and a cone detector. These are our preliminary proof of concept results, but in general I'm really excited about this research direction and we have a lot of cool new research coming out soon, so stay tuned. Thank you.